In the previous videos, I explained that investors can recover some types of their investments using the tax deductions. Tax deductions are categorized into two main categories: investment costs that can be expensed and investment costs that can be capitalized. Time is the only difference between two categories. If a cost can be deducted from revenue in full amount as tax deduction in the year that it is happened, it is called the cost is expensed. Costs such as operating costs are in this category, and if a cost has to be deducted from revenue in more than 1 year as tax deduction, it is called capitalizing the cost. Costs such as investment costs such as money paid for machinery, building, equipment, and so on are in this category. And also in previous videos I explained the depreciation as one method that we can capitalize some types of investment costs. There are four major methods for depreciation: straight line, declining balance, switching to straight line, and MACRS, or modified accelerated cost recovery system. I explained the first two in the previous videos, and I'm going to explain the declining balance, switching to straight line, and modified accelerated cost recovery in this video. So the third method to calculate the depreciation is called declining balance, switching to straight line. In this method, we for early years we use the declining balance rate, and for later years we switch to a straight line method. So in this method, we switch from declining balance to straight line depreciation method when the straight line becomes higher, gives us a higher depreciation than the declining balance in later years. So let's work on an example and see how we can calculate the depreciation using this method. So we are going to work on the same example, but we are going to consider the depreciation life of 10 years and the declining balance rate of 150%. So we calculate the depreciation for 10 years. Again, the first thing that we have to calculate is calculating the declining rate per year, which we divide the 150% of declining balance rate by the 10 years of depreciation life, and we are going to get 15% of depreciation or declining rate per year. So we calculate the declining balance depreciation for each year. We learned this method in previous video. For year one, the adjusted base equals $100,000 because the asset is purchased at $100,000 and the salvage value was 0. So the adjusted base is $100,000, and the depreciation for year one equals the adjusted base at year one multiply the depreciation rate or declining rate. And we are going to have $15,000 of depreciation for year one. For year two, we need to calculate the adjusted base first. Adjusted base for year two equals the adjusted base for previous year minus the depreciation for previous year. So $100,000 minus $15,000 equals $85,000, and it is the adjusted base for year two. In order to calculate the depreciation for year two, we multiply the declining rate or depreciation rate by the adjusted base that we just calculated, and we are going to have 12,752. For year three, adjusted base, to calculate the adjusted base, we deduct the depreciation of the previous year from the adjusted base of the previous year, and we are going to have $85,000, which was the adjusted base of year 2 minus the depreciation of the year 2, and we are going to have $72,250 dollars of for adjusted base for year 3, and the depreciation, which is going to be the adjusted base multiply the depreciation rate, and this is the depreciation for year 3. And we follow the same method for all the years, and we calculate the depreciation to year 10. So in the third column, we calculate the depreciation using the straight line. And to calculate a straight line, we use the adjusted based on that year. So for the straight line, we know that the depreciation is constant for for every year. So for in this row, we calculate the depreciation for 10 years using the value of using the depreciable value of this asset, which was $100,000, and we depreciate it for 10 years, and we are going to have $10,000 of depreciation per year. For year 2, we need to use whatever is left over. So we have $85,000 of the value of the asset to be depreciated, and we have 9 more years. So using the straight line, we are going to have we are going to divide the $85,000 by 9, and we are going to have $9,444 of depreciation for year 2 using the straight line. For year 3, again, we use the adjusted balance at year 3, and there are 8 years left. So we divide them, and we get the depreciation for year 3 using the straight line. For year 4, we follow the same method. The adjusted base for year 4 that we have it here, we calculate it here, divided by the leftover years. So we have 7 more years to depreciate this asset, and we divide the adjusted base by the years that are left over, and so on, and we calculate it to the year 10. For year 10, this $23,162 is the adjusted base that we calculated at year 10, and we have just 1 more year of depreciation, which is the year 10, and we are going to have this amount for depreciation at year 10. So in the next step, we have to compare these two columns and find the earliest year that the straight line depreciation gives us higher rate than declining balance depreciation. So as we can see here, until year 4, everything in this column is higher than this column. Starting from year 5, straight line depreciation gives us higher depreciation than the declining balance depreciation. So the year 5 is the year that we switch from the declining balance depreciation to the straight line depreciation. So the depreciation is going to be 15,000, 12,750, 10,838, 9,212, and for the 5th year we are going to have 8,700, and so on. In the first and second column, I wrote the declining balance depreciation and straight line depreciation. So as we can see here, year 5 is the earliest year that the straight line depreciation gives us higher depreciation than declining balance depreciation. So in this year we switch from declining balance to the straight line. So before year 5, we are going to have depreciation calculated from the declining balance, I wrote that in the last column. And at year 5, we switch from declining balance to the straight line. So we are going to have $8,700 of depreciation at year 5 based on the straight line depreciation method. So please note that this is the depreciation that we calculated based on the declining balance for year 1 in the column 1. Year 2 is the depreciation based on declining balance for year 2, year 3, and year 4. And year 5 is the year that we switch to the straight line depreciation. So we are going to have the constant depreciation for remaining years from year 5 to year 10. And again, please note that this depreciation is calculated based on the adjusted base and the remaining years. Another important thing about the declining balance switching to straight line is the summation of these depreciation from year 1 to year 10 equals the depreciable value of the asset, which was $100,000. So let's use Excel spreadsheet to formulate this problem and see how we can use a spreadsheet to calculate the depreciation using the declining balance switching to straight line method. So declining balance rate was 150%, depreciation life 10 years, capital cost was $100,000 and zero salvage value. The first thing we have to do is calculating depreciation rate, which is we have to divide this 150% by the 10% of depreciation life. So we are going to have 15% of depreciation rate or declining rate per year. So we have 10 years of depreciation. So I just write this 10 years here. The adjusted base for year 1 equals the capital cost because the salvage value is 0. Declining balance equals adjusted base multiply the depreciation rate per year, and because this is constant for all the 10 years, I fix this number, this cell. Adjusted base for year 2 equals the previous year adjusted base minus the depreciation that we calculated for the previous year, and the depreciation for year 2 equals adjusted base multiply the depreciation rate, and I fix this cell. So because I'm following the same equation for all the years, I can apply this to the other year. So this is going to be the adjusted base minus the depreciation for the previous year, and I will do the same for this one because I fixed the depreciation rate. So it is going to read, this cell is going to so Excel is going to read the depreciation from this cell, and it is going to read the adjusted base from this cell. So I can continue this and calculate these one by one, or I can just apply this to the later years and apply these to the following years. So this is the depreciation rates for 10 years using the declining balance. Now I will have to calculate the straight line depreciation. So please note that for each year I need to use whatever is left, the years that are left, and the depreciable value that is left. For example, for the year 1, I have $100,000 and 10 years to be depreciated. So I will just divide $100,000, which is the here. I just read it from here. The number of years. 10. And I'm going to have $10,000 per year of depreciation. So this cell is going to give me the depreciation for each year because this is a straight line. It is constant for every year. So for the second cell, I will use the leftover depreciable value of the asset, which is this $85,000, because we already received this $15,000 of depreciation as tax deduction for year one. And we are going to have 9 more years. So I'm going to formulate this in a way that I can just apply that to the other years. So I will use this depreciation life. I will fix it minus the year and plus 1, because this is the year 2, but I need to consider the year 2 as well. So this is going to give me the depreciation if I use a straight line. And again, this is constant for 9 years. So from year 2 to year 10, including year 9, including year 2, the depreciation is going to be $9,444 if I use the straight line. And I can apply these to the other years because I use the same equation. And for example, here for year 3, I use the adjusted base that I just calculated here, and this is the leftover depreciable value of the asset divided by 8 years. So I have this 10-year minus 3, which is 7, plus 1, and it gives me 8, and so on to year 10. So the next step is going to be comparing this column with this column. So the earliest year that the straight line depreciation method gives me higher depreciation than the declining balance is the year that I have to switch. So as we can see here, year 5 is the first year that the straight line is higher than the declining balance. So I will just highlight this. So in the next step, I'm going to write the depreciation here. For the first year, the declining balance is giving me a higher rate. For the second year as well, and year 3 and year 4. But for the year 5 is the first year that the straight line is going to be higher than the declining balance. So I will have $8,700 of straight line for the depreciation for year 5 and so on. So please note that this number means if you depreciate the leftover depreciable value of $52,200 of adjusted base for 6 more years, for the leftover 6 more years, you are going to have $8,700 per year. So this is going to be constant for 6 years. So from hereafter, I will switch to straight line, and for every year, this number is going to be constant and equal to $8,700 for each year. So for the 6th year, I'm going to have the same. For the 7th year, I'm going to have the same. For the 3rd year, for the 8th year, I'm going to have the same. Or what I could do here is I could just fix the row number here and apply this to the other years. So please note that very important thing here to know is in this method, the summation of all these depreciation per year for each year, the summation, the cumulative depreciation should be exactly equal to the $100,000 of capital cost. So to double check your calculations, calculate this summation and it must be equal to $100,000. So let's check, and yes, this is correct, and $100,000 of total. So the asset is fully depreciated and the investor receives the entire value of the depreciable value of $100,000 over 10 years.